Ready? Okay. So the whole idea that I want us to, learn today is more techniques of substitution. Now everybody knows what the substitution is about. It's about transforming the variable to make the integral possible when you do not have a direct standard integral. Understand? Now, how to eliminate some possible x or possible theta or whatever, it depends on the scenarios. And over the time, people have solved different problems and they have established certain scenarios, which is what we are enjoying today. Okay? And different questions come with different problems and require different scenarios. That's why you need to solve as much as possible to learn some of these techniques of transformation. Now, all these are quite easy because the derivative of this include x, which can be eliminated here. But this looks like product of three functions. Not really, it's just in disguise because these are power 4, so they can be merged as one. And once you do that, you realize, oh, the derivative of the function under the power is actually here. So that function under the power could be u. So my point is, the first thing you will write is to say this is integral x plus 1, everything to power 4, 2x plus 1 dx, which is now integral x squared plus x to power 4, 2x plus 1 dx. So now you are rest assured that if you let your u be x squared plus x, which means your du dx is going to be 2x plus 1, which is exactly what you want to eliminate. Okay? Then this implies that your dx swap du divided by 2x plus 1. And as a result, the original problem, integral x squared plus x to the power 4, 2x plus 1 dx is hereby transformed into integral u to the power 4, which is easy. 2x plus 1 dx, no, du, sorry. You know, the first bit my brain thought of Control Z, and I'm like, not on the board. Okay, so this becomes integral u to the power 4 du. That's the whole idea. And that will be u raised to the power 5 divided by 5 plus c, right? And if you put your u back, you get, what's our u? Okay, x squared plus x to the power 5, everything over 5 plus c. You don't have to break it down into this again, no. Okay, and that's that about that. For this one, similarly, O has done this. And it's easy to eliminate, right? So we shouldn't waste our time on this. Let's go to this. Clearly, there is no way you can let your u be x and produce ln x. But there's a way you can let your u be ln x and produce x. So that tells you what to do. So you say let u be the natural log of x, which implies that your du dx would be 1 over x. And if you cross multiply directly, your dx is equal to x du. That's very easy elimination, right? So, which implies that the original problem is equal to the natural log of 4x, the natural log of x, x dx. So, oh, this is u, right? So x cancels. What do we have now? 4 integral 1 over u du. This should be x du, sorry. Right? So, this is easy. So that is 4 with the natural log of u plus c. Okay? And your log can be negative. So we need absolute value. Because our u is natural log of x. And log can be negative. Right? The inputs cannot be negative, but the outputs could be negative. Okay? So clearly, this is 4 natural log of the natural log of x plus c. Okay? This looks tricky, but it's not. Most of the time, what you have here is your u. But without the power, yes, sir.
Don't you also need to put another absolute value inside that ln x?
You mean for this one?
No, the smaller one. Yeah.
I want to believe, they didn't put it in the question, but I want to believe it means x can be greater than 0. Since it wasn't put in the original question, then there's no need for you to put it in there. It means it's been cleared. Something like x greater than 0 from the beginning.
Oh, I mean, you just need it there to make sure it's not negative.
Here.
Yeah.
That's what I'm saying. That it's already been cleared from the beginning, from the question. If you have to put it here, it means you are in doubt of this. So why integrate something that you don't even know if it exists? But the fact that it's a function whose integral you're looking for, it means that function already exists. It's an integrable function. If it's an integrable function, it means ln x is defined. And ln x can only be defined when x is greater than 0. That is already settled. Okay? I didn't just put all the additional information, but that will have been a condition. You understand? But the fact that x is greater than 0 does not mean ln x is greater than 0. That is why there's a necessity. This is a necessity. Because x could be 0.2. If you check the natural log of decimal numbers, sometimes it's negative. Understand? Only when you get to 1, then you get 0. Check what is ln of any 0 point something. Somebody check. Negative. So that is why we need that. Okay? Until you move to 0. Remember, even the natural log function tends to, was it on the positive or the negative side? Until you get to that point where it is 0, then you get 1. Then other than that, it becomes large again. Right? Okay? I'm thinking of exponential graph, not natural log, sorry. But you get my point, right? Anyways. So similar, so there's no need for you to put another absolute value, that's my point. Because that should have been cleared from the beginning. Okay? Even though I didn't put it, but that is an assumption, we can assume that was the case. Okay? Alright, for this one now, you can try different things. But it is easier to make u cos. Somebody can try to make u sine and see what happens. Maybe you run into a problem or not. If you make u cosine, not cosine to power 5, just cosine. Because it's easier to work with u raised to power 4. Okay? Now you might be wondering, how do we eliminate this? Yes, it's going to be it's going to be possible. So let's u be cos x. Okay? If u is cos x, then du dx is negative sine x. The first thing will be, oh, but this is just one sine, and I have 3. How do I eliminate? Let's watch. From here, our dx is simply du, I can put negative here, sine x here. Agree? Understand? So clearly, my original problem, sine cube x divided by cos power 5x dx is equal to, I can split this into one sine. I don't have to. Okay, you don't have to. I don't just want to write another step. That's why I'm being lazy here. And this will be u to power 5 negative du divided by sine x. I can put that negative in brackets so it doesn't look like I'm subtracting, but I think everybody will understand because of that. I was just telling Clarissa the same thing. When this cancels, you're still stuck with the variable x, but you're not stuck because there's a relationship between sine squared and cos. Are you seeing that now? So this clearly gives the negative can be out. You have sine squared. That's why I said I don't have to do that, this splitting. I could have left it this way. One will cancel, and I'm left with this one. Divided by u to power 5, and I have du. And you can't say, oh, it's with respect to u, so this is a constant, comes out. No, it's not a constant. It doesn't work that way. But this is negative minus, no, 1 minus cos squared x, yes? Divided by u to the power 5 du, right? And your cos is u, which means you have minus 1 minus u squared, u to the power 5 du. Now this is a more reasonable transformation. We could eliminate this minus by swapping the position of the numerator. Agree? So that's what we're going to do. So I'll skip that and just write. I've swapped the position. Now I have u squared over u5 minus 1 u5 du. Understand? Yes? Understand? Okay. So this is 1 over u cubed. So that is u to the power minus 3. Integral u to the power minus 3 minus u to the power minus 5 du. So we are treating it like an algebraic function. Then later we can put back our trig. And that gives u minus 2 over minus 2, u minus 4 over minus 4 plus c. Yes? So, minus 1 over 2 u squared, yes? Plus 1 over 4 u to the power 4 plus c. Then you substitute back. So this will be minus 1 over 2 cos squared x plus 1 over 4 cos to the power 4x plus c. The same trick we're going to apply in the next question. Same trick. Clearly this is power 5, right? It doesn't even look like two functions, right? You break it into two. Sine x, then sine to the power 4x dx. But it doesn't mean that u can be sine x, because it will not eliminate this, right? But you can transform this into cos, right? Because this is sine squared squared. Sine to the power 4x is sine squared of x raised to the power 2. This is 1 minus cos squared raised to the power 2. So if you let your u be cos, then this will be 1 minus u squared squared. And the fact that your u is cos will give you something to eliminate the last sign. You understand? And all you have left is this algebraic function, which all you have to do is expand the bracket and integrate and put it back again. Do you understand that? So let's do this. So with this, we can say this is integral sine x. So I write first sine to the power 2x then squared dx, just so we understand. And this will be the integral sine x 1 minus cos squared x then squared again dx. So at this point, you say let u be cos x. It means our du dx is negative sine x. It means our dx is negative du over sine x. Can you see that we perform different tricks, even though they are similar for the last question and the current one? Okay? So, the original problem becomes integral. Of course, this is where we are, or maybe I just write the original problem itself, which is now this, will now be integral sine x 1 minus u squared squared du with a negative, of course, minus du over sine x. And that is reduced to minus out, right? If you open this bracket, 1 minus 2u squared, u to the power 4, yes? right? So, integrate now. Yes, tell me.
Wait,
U
minus
2u over 3
uh-huh.
plus u power 5 over 5 plus c.
But this minus, you don't have to put the C here. Okay, the C can be outside. Because minus C is still C. Then we put it back again, and that's all. So clearly, this gives minus, open bracket, cos x, right? Minus 2 over 3 cos cube x. Then plus 1 over 5 cos to the power 5x. Then plus c, close bracket here because of the minus. So, learn this technique. In the worksheet, there are similar questions like this and this. That's what you're going to try next. Okay? After I'm done with all this correction. Then towards the end of the class, I introduce something on standard integral. Maybe I'll give you another 10 or 20 minutes. Okay? Or maybe less. It depends on the targets. Okay? Alright. So let's look at this. Look at your standard integral that we wrote on the first day. Which of these can you integrate to give you the other? Can you integrate a cosec to give you cot? Or can you integrate cot to give you cosec? Check. It's going to be in your formula booklet. So if you're in the exam, you just have to check your formula booklet and see which of the function can produce the other function by derivative or integral, as the case may be. So derivative of cosec squared will give cot. Yeah. So integral of derivative of cosec squared will give cot, right? Negative cot, or the integral, you mean? Let's go to derivative instead. So derivative of cot gives negative cosec. Then this is your u. Understand? So we start by saying let u be cot 2x. Okay? It implies that, I'm not sure you can see what I'm writing, so you might want to change your position. It implies that the u dx, we have the couch, we have the whole couch here. Relax. We have the whole room to ourselves. So you can even sleep, but don't close your eyes. Alright. I hope you don't have food because both of you are here again. Alright. So the derivative of this is cosec, negative cosec what? Squared 2x. You don't have to memorize that, it's in your formula booklet. And we've talked about it before now. Which implies that if I want to make the x the subject, I'll be dealing with negative du divided by cosec squared 2x. Wait a minute. There's a 2 missing. There's a 2 missing. If you differentiate cot, you get cosec squared. But you have to multiply by the derivative of that function itself. Right? So in that case, we have this here. Apologies for that. Okay? So our original function, so the integral cosec squared 2x, you see because of the square, the 2x was put in bracket, times u, then times du over, there's a negative here, or you can just put the minus at the here, it's okay, cosec squared 2x. Because you know that cancels. So what do we have left together? This is not negative, this is my common sign, so let's get it. Negative 1 over 2 integral u du. That's what happens because this is not your uniform. So, what would that be? Negative 1 over 2.
U squared
U squared
over
2 plus C. So let's substitute back. Final answer will be what? Negative 1 over 4. Yes?
U squared.
No. Final answer now.
What? Oh.
Cot squared 2x plus C. The last two questions that I want us to try are high B questions. And I want to believe at this point you should be able to do number 8 yourself, based on the substitution we have done so far. In fact, they are so nice. Most of their questions, they tell you what to substitute. Okay? So this should be the one we will try together. And there's a similar question of this in substitution 2. In fact, I repeated this question in substitution 2. I put a similar IB question, but in that case it is root 2x, 1 minus root 2x. So it's going to be similar. So you should try that, okay? So let's do this together. But this you will complete yourself. I believe it should be easier now, especially with number 5 and number 4 that has been done. And you've been told what to substitute. Okay? All right, let's do this. You've also been told what to substitute. We have u is equal to that. Then we can find the u dx. So du dx, or we could first write, square root, sorry. So we could first write x to the power half, yes? So what's our du dx?
dx is
Half x negative half. So which is 1 over 2 root x. Okay? We can cross multiply immediately. Dx times 1 dx. And this times this. Right? So, which implies dx is going to be 2 root x du. Right? We might be stuck. Let's see. The original problem. The original problem, square root of x. Yes?
Isn't it 2 root x over 2
No. This is du over dx, right?
Oh yeah.
I didn't put that part again.
Yes, yes.
Okay? I write this way. This implies du dx is 1 over 2 root x. So it's easier to see. Okay? Please tell me if something is not clear enough. I left this space for something. This is 1 plus root x dx. So clearly this is integral. We don't know anything about this. This is our u. Is it? Then this is 2 root x du. It doesn't cancel. Can you see that? So clearly the only thing we have is 2 is out, x over u du. So we haven't really solved our problem. Okay? Then you go back. Maybe it's not the question because we assume we don't know. Even though I have done it, I was just doing some of them as you are working. I have done it. I already know that this is going to lead. This is what it's going to lead to. So let's pretend we're in an exam. You got to this point, you realize, oh no, it's not the direct one. Go back. You can still fix your mess. From here, u minus 1 is equal to root x, yes? Which means u minus 1 squared is equal to x. Everything has to be u. So you put it here. Integral u minus 1 squared over u du. It's 2. Now you're good. Understand?
Oh wow.
Understand? Mr. Chang?
Yes.
Lost?
No.
So everything has to be in the form of u. That's why. So what do? From this point, how do you proceed?
Expand.
Expand. integral, there's a 2, sorry, u squared minus 2u plus 1 divided by u du. What do we do next? Karen, you look lost, are you? Okay. Alright, yes?
We separate them.
Separate them. Split them into partial sums. What's the first one? U. Or you want to write u squared over 2? Or just write the expression?
It's right here.
Let's just write the expression. U, minus 2
plus 1 over 4.
plus 1 over u du. Is it okay to write this as u to the power minus 1? So it's integrable? Oh. If you write the u minus 1, when you add 1, you get 0, right? So that's not how we integrate this. What does this lead to? Yeah, the natural log. So we can write 2 into brackets. Yes, first one.
U squared over 2
Minus
2u
plus.
plus
Okay?
Plus C.
Plus c. Yeah, absolute value, thank you. Then plus c after the bracket. Then we substitute back. No, actually we can open the bracket. Okay? Open the brackets. U squared 4u to the absolute value of that. Substitute. What is our u? 1 plus 2x. Oh. 1 plus root x, sorry. Is it?
Yes.
Root x all squared. 4. Yes. 1 plus root x. Then plus ln 1 plus root x plus c. We can continue because you can expand. You have to simplify, okay? So we put it here. So open the bracket. Yes. 1, 2 root x, plus x, minus 4, minus 4 root x, then 2 ln absolute value 1 plus root x plus c. So finally, the integral is, this is negative, I don't want to put it first, this is negative, no, x is positive. Can you see that? Then I can put the root x next, 2 root x, then minus 3, then 2 ln 1 plus root x absolute value plus c. And this is your final result. Just 6 points in the exam. Okay? So, take notes, do some practice. So if you check your worksheets on integration by substitution 1, question 4. Okay? Question 4, maybe I pick some question that I need you to try. Okay? Based on these ideas. I want us to try, we have done number 3, which is my 4 Roman figure 8. So let's do 4 Roman figure 7. Let us attempt 4 Roman figure, we have done 17, right? Sine cube cos to the power 5, we've done that. Okay, let's try number 20 is not so cool. I think number 5 Roman figure 3 is cooler because it's power 5. Sine to power 5 there. Can you see? Then we could also try, of course I know you can do a lot on your own later, so I don't want us to waste too much class time on it. Please go to number 7. The substitution has been given already, so attempt number 7, C or D. No, A or D. A and D, yes. So let's see how fast you can be for these 4 questions. On page 1, 4 Roman figure 7. Also on page 1, 5 Roman figure 3. On page 2, 7A and 7D. All right? I will advise you not to waste time copying this. I want to see you try those questions, please. Okay? You can save the number of lines required, space required, and do the needful later when it is posted. So let's take, say, the next 10 minutes to attempt these 4 questions. Okay? You can turn that off now.